Today we're going to take what we already know about solving one-step equations of multiplying and dividing, and now we're going to include rational numbers. We're going to work through a few sample problems. The essential question is still the same as it has been for adding and subtracting and multiplying and dividing of integers, in that, how do I solve for a variable? Well, the 5 same steps still exist. I need to create my train tracks to separate the different sides to the equation. I need to do the inverse operation, which is also known as doing the opposite operation. I need to keep it balanced by doing the same thing to the other side. I need to solve and then check. My advice to you in today's lesson is to probably pause it, solve them, come back and look. Currently, right now in class, we are able to use calculators, so I feel as if you would be just fine if you had a calculator out. Just know that you need to show all of your work. In this particular example, the first thing you're going to do, as always, is set up your railroad tracks. Once I set up my railroad tracks, I then ask myself, well, what am I solving for? What am I trying to get by itself? What is the variable? In this example, the variable is A. Then I have to, within that second step, is say, well, what operation is happening right now? Well, right now, the operation is multiplication. So the opposite of multiplication, remember a few days ago, we said was division. So I'm going to divide by 7.2. Again, I'm going to practice writing that fraction bar for division instead of the dot line dot division sign, because I know that it's going to be more beneficial for me as we move forward. Step 3 says keep it balanced. So I can really just cut and paste this. I'm not going to, but I could. And divide that other side by 7.2 as well. I know that 7.2 divided by 7.2 turns into that gigantic 1. Which leaves me with just 1A. And then I divide. I know that a negative divided by a positive is a negative. And when I type 3.6 divided by 7.2 into my calculator, I get 0.5. I already knew it was negative, so I can have negative 0.5. Again, I'm going to go back and do my check just to make sure. My check would have me take 7.2 times A, where A is negative 0.5. And I want that to equal negative 3.6. Sorry, I ran out of room there. Negative 3.6. Again, I pull out my calculator, and I'm going to take 7.2 times negative 0.5. And I'm going to get negative 3.6. Negative 3.6 equals negative 3.6, so I know that my answer checks out. In this next example, I have negative 12 equals 4/5 x. Same thing, step 1, set up your railroad tracks. Step 2, I need to do the inverse operation. In order to do the inverse operation, I need to know what's happening right now. So I know that I want to solve for this x. I know that on the same side of that equation is this 4/5. And I know that right now they are multiplying. So the inverse operation to that is dividing. So I want to divide this side by 4/5. And I want to do the exact same thing over here. I want to divide by 4/5. When I type this into the calculator, I type it the exact same way that I see it. I'm going to type negative 12, then the dividing by sign, and then depending on what kind of fraction or calculator you have that does fractions, you might have to hit the 4 and then the ABC button, or the 4 numerator denominator button, whatever might work for you. Like I said, each one's a little bit different. But when I type that in there, you should come back with an answer. Again, these are going to turn into that gigantic 1. Because 4/5 divided by 4/5 is 1. Turns it into 1x. And then on this other side, if I have 12 divided by 4/5, it's going to give me an answer of negative 15. I go back and I complete the check. I know that negative 12 equals 4/5 times x, but that my x was negative 15. I plug that into the calculator, and when I plug it into the calculator, again, I type it in the exact same way that I see it. So this time I would write the 4/5 times sign negative 15, and when I do that, I get negative 12 equals negative 12. These are examples from the last lessons where they were not rational numbers, so if you wanted that, go ahead, pause, and come back. Hopefully for this one, you got an answer that D equals 72. Oh, this one shouldn't have that there. All right, so in this case, in this example, we have another fraction. What we're going to do is the same step over and over again. Step 1, draw my railroad tracks. Step 2, I'm going to ask myself, what is the variable? What am I trying to solve for? And I see that I want to solve for this x. I have to ask myself, what is bothering this x and how? I see that that x is being bothered by the 6/7 by multiplying, because when a number and a variable are right next to each other, they're multiplying. So the inverse operation to that would be to divide. So I want to divide both sides by 6/7. That brings us to finish step 2 and step 3. Now what I'm going to do is actually solve that. So I'm going to plug that into the calculator. Remember, when I plug it into the calculator, I'm going to type it the exact same way that I see it. So I see negative 5, then the divided by sign, then the 6/7. The biggest mistake kids made on this problem is that they forgot the negative part of the negative 5. When I do that and plug it in, I get an answer of negative 35 over 6. That is an improper fraction, so you can turn that into a mixed number by saying how many times does 6 go into 35? It goes in there 5 times with 5 6 left over. So if I turned it into a mixed number, it would be negative 5 and 5 6. You can try this problem on your own if you'd like. If you did that, you should have an answer of negative 72. All right, again, I'd hit pause and come back. Step 1, draw your railroad tracks. Step 2, I'm solving for D, and I ask myself what's bothering D. The negative 2/3 is bothering D by multiplying, so the inverse operation is to divide. Remember, we said that the negative 2/3 was bothering the D, so that means I need to divide by a negative 2/3. I need to divide by the exact same thing that was bothering the D. Otherwise, I would not be able to get my fancy 1. Whatever I do to one side, I need to do to the other. So I need to go over here and divide by negative 2/3. Again, I take out my calculator and type it in. In case you don't remember how to do that in your calculator, or excuse me, if you don't have a calculator, you don't remember how to do it, remember that when I divide, this would be negative 4 divided by negative 2/3. You may have learned all kinds of funny sayings for this. You may have learned KCF, keep, change, flip. You may have learned stop, drop, and roll. You may have learned some other saying or phrase. But really all that happens is that I keep the negative 4 like it is. The division turns into multiplying. And I flip this, whoops. Sorry, and I flip this fraction over so it's 3 over 2 instead. When I flip it over so it's 3 over 2, this is like 4 over 1, and I get to multiply straight across. A negative times a negative is a positive. 2 times 1 is 2. And 12 divided by 2 is 6. You would have gotten the same answer if you plugged it into the calculator. I can always go back and check my work. Negative 2/3 times 6, does that equal negative 4? Well, I know that a negative and a positive is going to equal a negative, so I know I did right there. I know that 2/3 times 6 is like 2/3 times 6 over 1. So this would be like 12 over 3, which is the same thing as 4. Again, your calculator could have helped you solve that if you had one, but that's the math that we had learned in the past that would walk us through. Again, go ahead, try it out. Decimals are no different from fractions. The first thing that I have to do is set up my railroad tracks. The next thing I need to ask myself is, what am I trying to solve for? And in this case, I'm trying to solve for x. What is bothering it? In this case, it's being bothered by that negative 7.3 by multiplying. So what is the inverse operation or opposite of multiplying is to divide. So I'm going to divide by negative 7.3. I need to keep it balanced, so I'm going to come over here and divide by negative 7.3 as well. Again, this is why we have our calculators. I admit I am not going to try to do this one mathematically as it's going to take too long. So in my calculator, I'm typing 58.4 divided by negative 7.3. And I get an answer of negative 8. Negative 8 equals x. I'm going to go back and check my work because I actually had to go back and change the button twice because I actually had a 9 in there. So I'm going to check and say, all right, I should have negative 7.3 times negative 8. And when I plug that in, I have negative 7.3 times negative 8. And I get an answer of 58.4. And that checks out to what I had before. Go ahead and try this problem. Again, railroad tracks. What am I solving for? This one's a little bit different than the others because it's starting off as a dividing. So I'm solving for that m. M is being divided by the negative 9.2. So the opposite of the dividing by is to multiply. So I'm going to multiply by negative 9.2 here, as well as multiply by negative 9.2 over here. These 9.2s actually make that funny 1 as well, but they're kind of angled from each other, so it makes it a little bit more difficult to draw it. All I'm left with over here is the m, and I'm going to take negative 3 times negative 9.2. I just don't trust myself today. And I'm going to get 27.6. It's a positive because a negative times a negative is a positive. There are examples like this where it's not multiplying or dividing in the traditional way that we know it. So I need to think of, well, what else is happening here? So in this example, I have something that is squared. We've already gone through this unit and we know that there's a relationship between the square root of a number. Let's say that I had the square root of 4 is 2, and the square of a number, that 2 squared equals 4. So the inverse operations in this example are the square root and the square. They are inverse operations of each other. So I'm going to come over here and I'm going to still draw my railroad tracks, but it's going to look a little bit different. Because in this example, the inverse operation of this squared, the inverse operation of that squared is a square root. Whatever I do to one side, I have to keep it balanced and do to the other. Again, I can type this into the calculator to get the answer, or I can look at that little chart that we had when we went over the square root unit, and I know that the square root of 144 is 12. As stated before, there's no reason to get any of these wrong because I can simply take that 12 and plug it back into the equation and say, hey, is 12 squared 144? Well, I know that 12 squared means 12 times 12, and yes, that is 144, so I know I did the problem correctly. There are examples, such as this following one, where it might already be square rooted, and I have to do the inverse operation of that. Well, if square root is the inverse operation of squared, then squared must be the inverse operation of square root. So right here, I have a square root. So to undo that, I need to square this. And if I square that side, then I need to square this side. This square root and this square cancel each other out. leaving me just with an x. This 4 squared becomes 16. As always, we can always go back and check our work. The original problem said square root of x, and we said that x equals 16. So the square root of 16 is 4. Go ahead, pause, come back, and see if you get the right answer. So in this case, it is a squared answer, so I need to take the square root. So what I'm going to do is draw my railroad tracks. I'm going to take the square root of both sides, and when I do that, I find that m equals 16. Hopefully you completed your check, but due to time, I'm going to keep moving. Take some time, pause, solve, and come back. In this problem, I already have a square root, so the inverse operation in order to solve that square root is a squared. Whatever I do to one side, I do to the other. That square and this square root cancel each other out, leaving me just with x. And I know that 11 squared, 11 times 11, is 121.